In this video, we're going to look at kites. I'm going to look at two different questions that were asked last year of kites. This one was in the November paper 2 exam, whereas this one was in the test that they wrote in term 3 on Euclidean Geometry. Let's start with the November one because I think it was a bit more straightforward and just basic from what we know of kites and using those properties. So the first one, we were told that ABCD is a kite. Such that the diagonals intersect at O. So first thing, we need to find the length of OB. Okay, now if you know your properties of a kite, you would know that the major diagonal, which is the one that goes from between the two equal sides to between the two equal sides, this one is your major, you would know that your major diagonal bisects your minor diagonal at 90 degrees. So for 7.1.1, finding the length of OB, is it will also be 2 centimeters, reason being diagonals of a kite. Then in the second question, they're asking for AOB. That's the second part we just said. The major one bisects the minor one at 90. Okay, so AOB is going to be 90 degrees. Same reason, diagonals of kite. The way that you know, even though you're working with an angle here, that the reason is the diagonals, it's because it's the diagonal that cuts the other diagonal at 90 degrees. Okay, so that's why we know it's the diagonals that make it so. Sorry, not dikes of kite. And then last question, ABD. So we need to go find this angle over here. Okay. Another thing that the diagonals do. Okay, so this question was all about the diagonals. So only the major one. It doesn't do that with the minor diagonals. Only the major diagonal bisects the vertex angles. So we firstly have that A, but it's O, between O and B, is also going to be 20. And this is also the diagonals that make it so. And then we have the 20, we have the 90. So ABD is going to be 180 because it's a triangle, right? Minus the 90 minus the 20, which is essentially just 90 minus 20, which is 70. And the reason for this is interior angles of a triangle. You could have also used sum of angles in triangle as well as sum of interior angles of triangle. Now, let's go look here at, this was also a kite question, but this was in the test. And they gave you 12 here, 2x and 5x. Now already because they were x's, it makes the question a little bit more complex. Okay, so they're telling us the area of the kite. And with the area, they want us to go find what x is. So if you know your theory from grade 9, then you should know that this is your area formula for a kite, which is half times the one diagonal's length times the other diagonal's length. And also, if you know your theory, which I really hope you do now, then you should know that, so this is called the major diagonal, right? And this one is called the minor diagonal. So that if this is 12, then this must also be 12. Okay, so let's quickly just write that down. So OC is equal to 12 because because of the dikes of a kite. Now we have 12 and 12, we have that, so we can go substitute. So half times AC will be 12 plus 12, which is 24, times with BD is going to be 2x plus 5x, which is 7x. And they gave us the area, which is 252. So this is essentially 12 times 7, which is 84x on the side. We can divide by 84 on both sides, and then we're going to get x is 3. So this is for 3.1, just this part is supposed to be first, right? Then this is 3.1. Then for 3.2, calculate with reasons. Okay, Euclidean geometry, everything needs reasons, not just if we say with reasons, please. Okay, just keep that in mind. They want us to find the length of DC, so we're looking for this length. Now, we don't know any of our outside lengths, but we just calculated what x was. Okay, they didn't ask you that to send you on a wild goose chase. They asked you because now you know what this length is, which 5 times 3 is 15. We know what this length is, so we can find this one if we remember that the diagonals of a kite are perpendicular to one another. Okay, so let's first go write down that DOC is going to be 90 degrees because of the diagonals of a kite. Then, now we can use Pythagoras. Okay, Pythagoras is very, very, very important. It's a part of every piece of maths. I love throwing in Pythagoras wherever they can fit in. Okay, so that's Pythagoras says the hypotenuse squared, which in this case is DC. We know DC is the hypotenuse because it's opposite the 90-degree angle. So DC squared is equal to the 15 squared plus the 12 squared. And we write down Pythagoras. Okay, and you do your best to spell it correctly. Then, when we add all of that together, we're going to get 369. We go square root, because that's how you get rid of a square. And you'll get 3 square root 41, which is 19,21. And then we just go double check, were we given any units? Yes, actually we were. There were centimeters squared there, so this is centimeters. And then you're done.